Okay, well, so as requested today, I'm just doing a quick video solution of question 2 on that pre-exam paper that I handed out today. So the question 2 is on complex numbers, which we can know because we have i's, and we're going to be answering the first question here. So we need to find the value of Z3, plot and label Z1, Z2, and Z3 in the Argand diagram. As always, I'm going to look at all the information I'm given and information I need to find out. Information I'm given is Z1 is minus 3 plus I, Z2 is 2 minus 4I, Z3 is Z2 minus Z1. So Z3 equals Z2 minus Z1, which is equal to 2 minus 4I minus Z1 is minus 3 plus I. So when we add or subtract imaginary numbers, we do real with real, imaginary with imaginary. So we do 2 minus minus 3i, 2 minus minus 3 gives me 5. Then we have minus 4 minus I minus 4i minus 1i gives me minus 5i. So 2 minus 4i minus minus 3 plus i gives me 5 minus 5i. Okay, now what we're going to do is we're going to plot those three points on the Argand diagram. So the first point we do is minus 3 plus I, minus 3 on the real, up to 1 on the imaginary. This is where Z1 is. Next we have 2 minus 4i, we go out to 2 on the real, down to minus 4 on the imaginary. Z2 is down here. Lastly, we 5 minus 5i, go out to 5, down to minus 5, that's Z3. Okay, so that's the first question. We just find what Z3 is, plot our 3 points of the Argand diagram. Now question 2. From your diagram, is it possible to say that the modulus of Z2 is greater than the modulus of Z1? So remember, when we have lines on either side of our imaginary number, it means the modulus. If you don't remember what the modulus means, it means the distance it is on the Argand diagram from the middle point to the point 0, 0. So can we say that the distance that Z2 is from 0, 0 is greater than the distance Z1 is from 0, 0? Yeah, we can. Yes. Z2 is visibly further from 0, 0, also known as the origin 0, 0, than Z1 is. Now we're going to verify that algebraically. The way we're going to do that is by calculating the modulus. So we need to calculate the modulus of Z1 and calculate the modulus of Z2. So remember, when we calculate the modulus, we're using Pythagoras theorem. So if we're looking at Z1 and we're finding the distance Z1 is from the modulus, well, we went out minus 3, so the bottom has a length of 3, and we go up 1i, so this has a length of 1. Pythagoras theorem tells us that modulus of Z1 squared equals 1 squared plus 3 squared. Modulus of Z1 squared equals 1 plus 9, which is 10. So the modulus of Z1. To get rid of the square, we do the opposite on the other side, square root of 10. Modulus of Z1 is the square root of 10. What about Z2? So Z2 is down here. So to get to Z2, we have to go across 2 and down 4. So this triangle looks a bit like this. 4, 2, and this is the modulus of Z2. So to find the modulus of Z2, modulus of Z2 squared equals 4 squared plus 2 squared. Modulus of Z2 squared equals 16 plus 4, which is 20. So then Z2 equals the square root of 20. It doesn't tell us what the unit is, so we don't have to write in centimeters or anything like that. That's our full answer. So this question is hard if you don't remember your notation that this means modulus. If you know what modulus is and how to calculate it, it's an easy question. Okay, let's look at the rest of the sheet.